Wireless NIC. Wireless deployments require a minimum of two devices that have a radio transmitter and a radio receiver tuned to the same radio frequencies. Any device with wireless NIC is a network device such as router, wireless router or wireless AP. To communicate wirelessly, laptops, tablets, and smartphones, and even the latest automobiles include integrated wireless NIC that incorporate a radio transmitter or receiver. However, if a device does not have an integrated wireless NIC, then a USB wireless adapter can be used as shown in the figure. Wireless home router. A wireless router is commonly implemented as a small business or residential wireless access device. The wireless router advertises its wireless services by sending beacons containing its shared service sets identifier or SSID. Devices wirelessly discover the SSID and attempt to associate and authenticate with it to access the local network and internet. Most wireless routers also provide advanced features such as a highly speed access, support for video streaming, IPv6 addressing, quality of service or QoS configuration, utilities, and USB port to connect printers or portable drivers. Wireless access point. While range extenders are easy to set up and configure, the best solution would be to install another wireless access point to provide dedicated wireless access to the user device. Wireless clients use their wireless NIC to discover nearby APs advertising their SSID. AP categories. These are standalone device configured using a command line interface or a GUI. As shown in the figure, autonomous APs are useful in situations where only a couple of APs are required in the organization. A home router is an example of an autonomous AP because the entire AP configuration resides on the device. If the wireless demands increase, more APs would be required. Wireless antennas. Omnidirectional antennas such as one shown in the figure provide 360-degree coverage and are ideal in houses, open office areas, conference rooms, and outside areas. H02.11 wireless topology modes. Wireless LANs can accommodate various network topologies. The H02.11 standard identifies two main wireless topology modes: ADHOC mode and infrastructure mode. Tethering is also a mode sometimes used to provide quick wireless access. BSS and ESS. A BSS consists of a single AP interconnecting all associated wireless clients. Two BSS are shown in the figure. The circle depicts the coverage area for the BSS, which is called the Basic Service Area or BSA. If a wireless client moves out of its BSA, it can no longer directly communicate with other wireless clients within the BSA. H02.11 frame structure. Frame control. This identifies the type of wireless frame and contains subfields for protocol version, frame type, address type, power management, and security settings. Next one is duration. Duration is typically used to indicate the remaining duration needed to receive the next frame transmissions. Address 1. This usually contains the MAC address of receiving wireless device or EP. Address 2. This usually contains the MAC address of transmitting wireless device or AP. Address 3. This sometimes contains the MAC address of the destination such as router interface, default gateway to which the AP is attached. Sequence control. This contains information to control sequencing and fragmented frames. Address 4. This is usually missing because it is used only in ADHOC mode. Payload. This contains the data for transmission. FCS. This is used for layer 2 error control. CSMA or NCA. WLANs are half duplex shared media configuration. Half duplex means that only one client can transmit or receive at any given moment. Shared media means that wireless clients can all transmit and receive on the same radio channel. This creates a problem because a wireless client cannot hear while it's sending, which can make it impossible to detect a collision. Wireless Client and AP Association SSID. SSID name appears in the list of available wireless networks on a client. In larger organizations that use multiple VLANs segment traffic, each SSID is mapped to one VLAN depending on the network configuration. Several APs on a network can share a common SSID. Password. This is required from the wireless client to authenticate to the AP. Network mode. This refers to 802.11 ABGN AC ED WLAN stands. APs and wireless routers can operate in a mixed mode, meaning that they can simultaneously support clients connecting via multiple standards. Security mode. This refers to security parameters settings such as WEP, WPA, or WPA2 always enable the highest security level supported. Channel setting. This refers to the frequency bands used to transmit wireless data. Wireless routers and APs can scan the radio frequency channels and automatically select an appropriate channel setting. The channel can also be set manually if there is interference with another AP or wireless device. Passive and active discover mode. In passive mode, the AP oftenly advertises its service by periodically sending broadcast beacons frames containing the SSID's supported standards and security settings. In active mode, wireless clients must know the name of SSID. The wireless client initiates the process by broadcasting a probe request frame on multiple channels. Split MAC architecture. A key component of CAPOP is the concept of split media access control or MAC. The CAPOP split MAC concept does all of the functions normally performed by individual APs and distributes them between two functional components. AP MAC functions, beacons and probe responses, packet acknowledgements and retransmissions, frame and packet prioritizing MAC layer and data encryption and decryption. WLC MAC functions. Authenticate, association and reassociation of roaming clients, frame translation to other protocols, termination of 802.11 traffic on a wired interface. DTL's encryption. DTLs is a protocol which provides security between the AP and the WLC. It allows them to communicate using encryption and prevents eavesdropping or tampering. Flex Connect APs. There are two modes of operation for the Flex Connect AP. First one is the Connect mode. Connect mode is WLC is reachable. In this mode, Flex Connect AP has CAPWAP connectivity with its WLC and can send traffic through the CAPWAP tunnel. As shown in the figure, the WLC performs all its CAPWAP functions. Standalone mode. The WLC is unreachable. The Flex Connect has lost or failed to establish CAPWAP connectivity with its WC. Channel selection. A best practice for the WLAN requiring multiple APs is to use non-overlapping channels. For example, the 802.11b GN standards operate in 2.4 GHz to 2.5 GHz spectrum. The 2.4 GHz band is subdivided into multiple channels. Each channel is allotted 22 MHz bandwidth and is separated from the next channel by 5 MHz. The 802.11b standards identifies 11 channels for North America as shown in the figure. Plan A WLAN deployment. The number of users supported by WLAN depends on the geographical layout of the facility, including the number of bodies and devices that can fit in a space. The data-rich users expects the use of non-overlapping channels by multiple APs in an ESS and transmit power settings. Main in the middle attack. In a man in the middle attack or MITM attack, the hacker is positioned in between two legitimate entities in order to read or modify the data that passes between the two parties. There are many ways in which to create a MITM attack. A popular wireless MITM attack is called the Evil Twin AP attack, where an attacker introduces a rogue AP and configure it with the same SSID as a legitimate AP. As shown in the fig, locations offering free Wi-Fi such as airports, cafes, and restaurants and particularly popular spots for this type of attack due to the open authentication. Next is frequency channel saturation. Wireless LAN devices, transmitters, and receivers tuned to specific frequencies of radio waves to communicate. A common practice is for frequencies to be allocated as ranges. Such ranges are then split into smaller ranges called channels.